Hi, my name is Damián. I'm working in Datadog in OSPO. I'm going to talk about the role of package managers as partners in license and attribution compliance. Very long name. I'm going to get into what that means. So what we want to do? We want to distribute digital artifacts. It could be software, it could be assets, it could be sounds, or any other thing. It's not specific to code only. And we want to comply with the licenses attached to this. We want to reuse things that others did. They put a license to it. We want to comply. And some of those licenses have attribution requirements. So how we attack that problem, we get some tool. We find some tool in the internet, we go, we run it through our project, we get all dependencies, we get all the licenses, the attributions we need to do, and that's it. In reality, that tool doesn't exist. There is a lot of different tools that solve partially the problem. There is SCAs, there is clearly defined, there is SBON generators. There is plenty of things that tackle just a little piece of the problem. And I'm going to go into details what Nosita attacked later. So we tried to use some tool and we couldn't find one. So the next problem is, okay, we make one. And I tried, and it doesn't work. And I will go into why. Things have dependencies. We have our code. We know the license our code has. We know the attributions we want to put into it. We can even go into what is an embedded dependency, so copy-pasting some code into our code and keep track of that. But our project usually has some dependency into something that someone else did. And when we have that dependency, that we call declared dependencies, we have maybe 10, 12, depending on the project, we might have more. We can go and check. It's not that many. Thing is that each of those dependencies normally has more dependencies. They declare their own dependencies. And simple projects, depending on the language, easily go over hundreds quickly. And those transitive dependencies start to be really hard to track. But also, they are not only hard to track. Every time you modify one of them, they might cascade into a sequence of changes to all down the dependency tree. You update a version, one of the dependencies of that version you updated changed the framework they were using. Now you have 200 changes into your dependency tree. So the transitive dependency problem is huge to monitor daily. And in particular, for compliance, we are not looking into the dependencies of everything that we use into our project. We're particularly interested in what we are redistributing. We want to be compliant to licensing and make attributions of things that we are passing as part of our project. So where do we find all this metadata, all this license attribution information that is into our dependencies? There is no common place, but we know that everything that is modern development, we follow these package manager frameworks. You want to do some project in Python, usually you use PyPy or something else to handle all the dependencies. You declare it in a format particular to that particular package manager. You work in NPM, you use package JSON or Yarn. So let's look what package manager can provide and what we would like to add to them to complete the requirements of what we want to do. So the first thing is we have this artifact that is the content, the package, the code you write, and that's only a part of the package. In addition to that, we have some metadata associated and a requirement description. We say this package has a name, a version, a license, and it requires all these things to be built. And then we have a package management tool that will interpret that metadata we attached to the original project to compose new projects from it. So in this ecosystem of package managers, we have barely 4 roles that are distinctive. And the 4 of them could be the same person. It doesn't have to be different persons. So we have one role is the dependency maintainer. The dependency maintainer is people writing code or creating documentation. They are the authors. And they have the collective knowledge of what's the license and attribution you want to do. You're writing your own code, you're in your team, you put some license to it, you know where to find it. You put it in some directory somewhere. People from outside the project might not find it, but you know what you want to, what is your intention. And they are not necessarily connected to a package management. There is plenty of projects that are created without any package management declaration. They don't put some metadata to say this project belongs to PyPy and is built this way, mostly because package managers can be multiple package managers packaged in the same project. So the second person will be the package maintainer. Package maintainer is people who get projects, they see them as kind of like a black box, as content, and they adapt that project to be packaged and shipped through tools. They do the metadata preparation, they might do some rearrangement of some parts of the project to make it compliant to the package management specifications, like putting files in certain place, changing the structure of the directories, or passing flags to a compiler. And finally, they publish the package into some registry. Package consumers, they are building new projects that has dependencies. When they build these projects, they do some declarations that the package management tools will require to find the dependencies and to make the composition required to build the final project. They are the one composing what you want to distribute. Then we have the package management developers. The package management developers set the rules of how all the 3 others interact with each other. They set the format for the metadata, the place where you need to upload or download things, the tools you need to use. And they develop these tools. In many kind of package managers, there is specifications and tools for separate. In some of them, the tools are the specification. So we have the roles of what people participate. They inform each other priorities on development. And we have plenty of package managers. So in the last 40 years or so, the package management industry changed, but barely they follow some pattern, if we really simplify a lot. So we have like 3 kinds of tools. A publication tool, which is what package managers, maintainers do, package maintainers do for managing, running linters, making adaptations of the source code to a package format, and push it into some registry. Then we have some registry, which is an abstract registry. It doesn't have to be a central authority. It could be distributed. It could be, in the case of Golang, it's going to be just addresses into GitHub. If it is Python, it will have some central authority like PyPy. Or if it is JavaScript, it's going to have multiple authorities depending where you're pulling things from. And then we have the combining tools. The combining tools is the tool that will read your configuration of your project, say, these are my dependencies, I bring all this together into my project, and I build it, and this is the result. So some examples of how package management metadata looks like and the process. One of the first package managers was BSD ports back in the 93 or so. It was based in conventions in makefiles. There is a central authority that is based on PRs. And the specification is the Porter's manual. It's a very long manual with all the details of how you build a package. At the time, it was very intuitive for devs. Writing makefiles in '93 was common procedure for anyone. And it's based on patch mechanics. So every package will include both the original source code you're shipping, a set of patches that need to be applied to it to be conformant to the standard, and the tools for running and building. The origin of the source code is duplicated completely into the package manager. So every time you get the package, you get the original source code. This doesn't happen in every package manager. And it has features to scope what is going to be distributed and used for each step of the package management tool. Yeah. So this is a standard from 40 years ago. It comes like this. This is just an example from an application that is right now published in the package manager. It's Electron, and it looks like that. That's the data as you get it from the manufacturer. Yeah, that's what's in the port 3 weeks ago. So yeah, it has some important things to notice, but there is like, if you check, there is something that says fetch depends, extract depends, patch depends. All those that says depends as a suffix are different tools that are used when you fetch the package, when you patch it, when you build it, when you run it, and when you test it. And the thing is that in this one, what you run is what you distribute. So anything that is a depend that goes into the run depends tree is going to be the things you want to attribute and comply to the licenses when you're doing redistribution. So another example is years later, Debian. Debian added, in top of what FreeBSD had, a way to standardize the way you publish you acknowledge licenses and attributions in some standard called EP5, which is peer monitored when you go into stable. Debian provides tools for linting and validation before you go into a PR. And they have a different setup on how you distribute things. They bring the source code from the original project and a modified version of the original project that is used for building in the package manager. It's not the original plus patches like in BSD. The scope is not a feature in Debian. It was removed. So in this place, you cannot make any difference between what you distribute and what you consume for other purposes. So the de facto standard was created naming packages with suffixes. There is suffixes for headers, suffixes for development, and a lot of things that try to fill this gap by using naming conventions. Then, at some point, if you're doing development, everything moved into language-specific package managers. The generic ones were development tools anymore. And there was kind of two different approaches. One was Python approach. Python has a standard, the PEP. They defined the format of the file that defines a project and its dependencies. The current one is PyProject TOML. But it evolved in the standard in many different ways. And it ended with multiple fields that have overlapping concerns. So you have like 5 different ways of defining a license. One of them is SPDX1, one is SPDX2, and there is a lot of other different ways. You can reference files, for example, or copy-paste the license there. And all of them are different fields with different names. But something that is key in Python is that the only 2 mandatory things you need to do is name and version. There is no requirement that you do anything else. You don't need to declare licenses or anything. The original code doesn't require to be there, so usually what you get is URL to the original repository. The original repository might be offline 6 years ago. You don't see it. There is no way to recover the license or attribution from the original project. And scoping doesn't exist in Python. There is optional things you can add, but there is no scoping. The last one I'm going to show example is JavaScript. JavaScript has, different to Python, has multiple standards. What happened in JavaScript is the community was distributing no packages code around the internet for a long time. There was no part of a standard that would address it. So NPM created its own standard. And then others came and created different standards. So there is an NPM standard. There is, for example, Yarn, that is a variation of the NPM standard. The focus of the standard is on bringing different scopes, but the scopes doesn't match the process of the package management. What they have is like roles that some package might have in your project. So you have dev dependencies. So when you're building the package, it will pull it, but it will not pull it when you are consuming it. It has peer dependencies. That means that you have interface between two packages that are in your dependency tree. And it has something interesting, which is the bundle dependency, which is a concept where you are uploading a dependency that internally has already the code of another dependency. So when you do a bundle dependency, technically you are redistributing code, and you should be able to do license and attribution properly already. So why are package managers are not more consistent in what they do? So they have very different goals initially. FreeBSD and Debian, they wanted to ship software, libraries, everything they could, so it could be used in their operating systems. But Python, for example, was trying to make easy to build applications in Python, not focusing on everything else that is in the system. Even they provide ways to abstract from the system completely. JavaScript was focused on trying to distribute deployments more than actually development. Then we have different inception text context. When Python was created, the package management, it was 20 years after FreeBSD. Make files were not the thing anymore. For example, PHP will use ini files, which were a thing when they created package management. Python will use TOML now, but before they used something else. JavaScript will use JSON because the context of developing JavaScript makes sense to have JSON files around. Java will use XML. And then we have the priorities of the different communities were different. While Python was focusing on mostly research and data science in some part of its history and redistributing as code. NPM was lacking funding, so you get a specific place where you can declare, I need money, and you get a warning when you're building the package. So it's different context for each of the communities. They lead it different ways, but barely they got into this kind of publication, repository, and distribution composition. So why they don't adopt some standard? So there is basically two kinds of standards right now. One is the open chain. Open chain focuses on processes, on relation between companies, between people, things you need to document on your process, and how your development cycle is defined. But it doesn't cover how a package will pass information to the next one when it's packaged. So it doesn't go into the details, it goes into a process. But the process, you need to fill it yourself. So the second option is SPDX or CycloneDX or something similar that defines how SBOMs are constructed. Software bill of materials have a track of everything you have into your distribution. But what the standard defines is the final product. You need to build it. There is no standard on how to build it, how to get from the original first package in your tree, how that one will pass information to the other one and to the other one and to the other one, so you get the final SBOM. And if you're doing modern software, you need to add that nothing is single language anymore, so usually you deal with 2, 3, 4 different languages at the same time, with 3, 4 different package managers at the time, which all of them have different formats and logistics. So what's next? What can we do? So one thing that we need on this community, that they have the maintainers, the developers, the package management developers, and the consumers, is add OSPOs into it. We need to be part of this influence cycle. We need to contribute into how package managers are designed, how they are used, and motivate the people to take into account our license and attribution compliance requirements. So how we do that? We can start talking to people, add contributions to package managers, find a common minimum requirement of metadata that we want to have in those package managers. Try to add the scoping into them. Without the scoping, there is no way we can trace back. So for me, what I'm doing is I'm in the to-do OSPO in a Slack channel. I will be in the topic tools channel if someone wants to join the discussion with me and others. We are trying to figure out what will be some minimum requirements we want package managers to move through the dependency tree and try to contribute them. Go to those projects. All or almost all are open source, and we can propose and change these things. There is some success story already. SPDX expressions were added to most of them. And if SPDX expressions were added, and we find what's missing now to do the next step, we might be able to push it. So now is a call for anyone who wants to help. I will be there. Contact me anyway. That's my contacts. And thank you. Someone wants to ask questions or anything? Yeah. I don't.
How aware are you of projects like devs.dev and ecosystems that are attempting to ingest data from package registries and then present it in a more structured way? And assuming you are aware of them, what gaps do you see there that require actually working with the package registry ecosystems?
So the thing that I'm most familiar of those kind of projects is with clearly defined. So the idea in clearly defined is that they will pick up a package, they will go through the dependency tree, they will use multiple tools like FOSSA or Scan Toolkit, all these tools. They will extract the metadata from the Python package manager, and then you have a crowd-funded approach to do curation of all the data that there is. The problem is that that data is intrinsically bad data from the start, because Python will tell you the dependencies differently depending if you're running different subversions, if you're doing different parameters, if you're doing different platforms at the time you run the command. Even if you go from a Mac M1 to a Mac Intel, it will have a different closure of dependencies at the time of build. And it's based on it's assuming that things are freezed. Like most dependencies are not pinned in the wild, so every time you build is a different closure. And if you are using the static data that was generated from them without the scoping, you are usually getting like a superset of what you should be getting, because you get all the dependencies of the building tool, all the dependencies of the testing, all the dependencies of fetching or whatever you need in the process of the pipeline. And all that is not in the distribution. And for certain licenses, that is even a problem because, for example, let's say you have a BSD4 license that says that you need to do Berkeley acknowledge, yeah? And you are pulling one of those random dependencies you get from there is the compiler. The compiler is not redistributed, and you are acknowledging University of Berkeley, but you're doing false advertisement because they are not part of the distribution. Or you start getting in gray areas at least. you get this. The other thing is you might not get some stuff because, for example, if you do a scan code toolkit, you build it in 2 different platforms. At the point when they cross the barrier to C, they start using different libraries. And you don't even pick them from the clearly defined. They don't see it.
Okay, thank you.
I think definitely a good point. You should follow up with ecosystems and deps.dev. I think ecosystems I've definitely seen here. I'm assuming deps.dev people will probably be around. Yeah. And so for the direction you're leaning, they are pulling lots of content out of the package managers and probably not in the direction of the clearly defined, let's get all the attribution cached today. But that might just be a conversation you need to encourage them on, to be thinking about this use case if they're not today. I think one of the things that I think is sort of needed here is as we bring SBOMs in and we start seeing SBOMs showing up, we actually need to get the lawyers and the original projects to change their positions on what they wrote in licenses 30 to 40 years ago. Yeah. Frankly, I don't need to include a copy of the Apache license. The letters Apache 2.0 are good enough now, right? So now our SBOM could just have a word, even though the license says you have to include a copy. It's boring, it's not needed. GPL2, all of these things. I think one of clearly defined challenges was how to make it correct with all the like we saw in your BSD ports example, right? So many different licenses inside one package. That's the challenge of how to get that from the SBOM and the ORs and the ANDs. And it's also very similar to VEX is a big topic at the moment, where you've got your SBOM, you've got your CVE says, there's a security issue. And then VEX comes along and says, but not in this use case, we're not using that problem. That's very similar to the Mac build has LGPL3 something, but the Windows build doesn't. And so you start having that reachability analysis of trying to figure out what's where. So if you can get people, when they're thinking VEX, to also think about obeying the license at that point, you might be able to do a feed 2 birds with 1 hamburger or whatever the saying is supposed to be now.
Yeah, something I saw recently in a project was not even getting into different platform, like platform in the sense of operating system, but deeper. We had this project, cannot get the name, but the project is an LLM, and the LLM will choose different library to run, to build, depending on the drivers of the NVIDIA card that is attached to the instance where it is built. And what attribution you do from that? I ran it in my machine. It never went that bad. And the package manager doesn't have, at least for Python, it will not tell you what will be the resolution for another platform. You cannot ask for what happens if I run it in, same build, I run it in other. It will only do it if the will exists, and the will doesn't always exist.
And I think something we have to expect will happen again, doing the kind of respect the past scenario is 2010s or so, we had a whole bunch of lawsuits because people weren't obeying licenses, and this led to devices going off shelves. It wasn't the most public thing, but there were costs to not getting this stuff right. And I think when I look at some of the LLM science packages that come out now, there's a lot of kitchen sink in those packages. They're big. And I got to assume there'll be some people unhappy with each other who use this as the fulcrum to argue their unhappiness. So definitely, although we've been quiet on this topic for a few years, it feels, it's an easy one for companies who are unhappy with each other to use as an argument point. So a good one to still be doing pretty damn good at. Questions, anyone? I'm giving opinions and just thoughts, but
It's great. Thank you.
I'm wondering about Nix and Nix packaging, and because they repackage stuff from other repositories. Are you familiar with the Nix package manager?
No.
Oh, okay. Well, it's got a lot of packages, for Linux and development, also on Mac.
Okay.
It's
like Brew or RPM or so many.
There's I can't remember the name of the website, but there's a graph of package availability to number of fresh packages. And the graph is Deb, RPM, the Arch user repository. And this is Linux, of course. And then Nix is way up there. So there's a lot of Nix packages, and they repackage stuff from NPM and from Python, and they have their own metadata that they record. And then I don't know. I guess I was curious if that had been
No, I don't know that particular one. But yeah, basically, it was more common when there was no package manager per language, that you have everything falling into this Debian. But when you have it in Debian, you also have it in the port tree, you have it in RPM, you have it in every distribution operating system had one at some point. Now they are kind of, at least there is 3-4 that are majority. But when you get into the language package managers, it's weird because many things just disappear. There is things like, I don't know, in Python and PHP at least, there is almost everything has a dependency in C at some point. And that one gets just pushed into, and if someone remember they put some note there, but that one disappeared. You go into PCL, which is the repository for PHP, most of them say the top level package that license, and that's it. It will not go all the way down. And I don't know, CPAN doesn't have much of it because it was the first one in the language specific, so it doesn't have any mechanism to do. PHP at least has two separate repositories, one for those that are pure PHP and one that is, this has something else, look for it. Python doesn't have it either. Sometimes you get the dependency declared, sometimes you don't get it. Sometimes it will say this contains big text in the PyProject file. It's different for each package manager, and something I think in some areas they need to start converging. It's 40, 50 years of package management now. And the license SPDX ID and the SPDX expression was one of the first things they converged into. Not all of them yet, but you can use them in Python, you can use them in JavaScript, you can use them in Conan. There is many package managers that are taking it now. And I think we can try to get into that and get 2-3 more things there. Or maybe if SBOMs really start picking up, the thing is, if we define SBOM for everything in the chain, and the package manager is aware on those SBOMs, and they make composition, but for that is asking for a lot more. So maybe what we need is a minimum things that eventually will become a SBOM in 20 years. But the minimum that we need today, we need to define what it is and try to push it into package managers. Because clearly defined approach of everything's wrong and we curate it manually in groups doesn't scale. Every time someone upgrades one package, the whole dependency tree can change. I don't know, I was dealing with it, with this thing for a few months, and but
Thank you.
thank you.